Welcome to this segment again of limiting reagent. So we want to further amplify on limiting reagent. So like we defined it, a limiting reagent is simply a reactant that is completely consumed, or if you want, you can say used up in a reaction. So that is what we call as being a limiting reactant. Sometimes it's called a limiting reagent. And the reason is because it determines or limits the amount of product formed, while the other reactant is simply called the XX reactant. If you remember from my previous video, for example, if you have hydrogen reacting with oxygen to produce what we are calling as being H2O, in this case, balancing up this one, we have a 2 there, and we are going to have again a 2 there. So you can see that, when it comes to the reactant, this is what we are calling as being reactant, and what we get at the end of a reaction are what we simply call as being product. So for the limiting reagent or reactant, sometimes we call it as being sometimes a reactant. You're going to find it has to do with the reactants this side. So between hydrogen and oxygen, there's one that is going to be in excess and there will be one that will be limited. So how can you determine which one is the limiting reagent? Remember what we said, you can first of all, use the mole ratios in this case. So you can actually use the mole ratio to determine which one is the limiting reagent from what you have been given. Now, if the mole ratio, you notice that it is 2 to 1, remember, you can actually go further and, and highlight which one specifically between the two is actually a limiting reagent. You cannot just use the number of moles you calculate for this and that and you conclude to say it is the limiting reagent, because the mole ratio is not 1 to 1, it is 2 to 1. It simply means that you need to prove that one further. So the one where we say, when you just calculate the number of moles, and the one with the smallest number of moles is a mole ratio, is where you are having, in this case, the mole ratio being 1 to 1. For example, magnesium oxide reacting with sulfuric acid to produce what we are calling as being magnesium sulfate and H2O. This equation is already balanced. And if you notice the mole ratio, the numbers in front of the reactant is 1 to 1. So when the ratio of the reactant is 1 to 1, you just need to determine, in this case, the number of moles. So the one that has the smallest number of moles here, that is going to be the limiting reagent. But that's not true. When the mole ratio is not 1 to 1, then you need to probe further into the equation by using the mole ratio from the balanced chemical equation. In simple terms, the mole ratio that you are going to calculate, you need to compare it with the mole ratio from the balanced chemical equation of the reactants, and that will assist you. Well, let's try to look at an example and see how you can determine the limiting reagent. I have a question that is already highlighted here. I've already written it there. So it simply says 5.6 grams of iron burns in 6.4 grams of sulfur to form iron 2 sulfate. Or in this one, I think I left an equation here. They had actually given you that. So Fe plus sulfur to produce what we are calling as being iron, sulfide. So that's the equation they had already given you, which is already balanced. So now the question there says, calculate one and find out which reactant is the limiting reagent. So they want us to determine which one is the limiting reagent. So now if you notice, I've got iron reacting with sulfur, and when these two react, they produce what we are calling as being iron sulfide. So that is what is being, produced there. So basically, that is what we mean. So now, how do we determine which of the reactant is the limiting reagent? Remember, they have given you the masses that you can use. And from here, they have told you to say iron, the mass of iron that was used was 5.6 grams, and the mass of sulfur was 6.4 grams. So from there, we can actually get to know the limiting reagent. So what am I going to do? I'm going to find the number of moles of iron. Remember, number of moles is mass. over the mixture. In this case, the mass is 5.6 divided by the mixture of just iron, because we are just talking about Fe iron, which is 56. Therefore, the number of moles there, if you divide using your calculator there, 5.6 divided by 56, that is going to give me a 0.1 mole of iron. I'll also do the same with sulfur. So I'll say the number of moles of sulfur will be equal to the mass divided by the mixture of sulfur. So the mass is 6.4 divided by the mixture of just sulfur alone there, which is actually a 32. So if we divide 6.4 divided by 32, it is simply going to give us the number of moles that we are going to have will be 0.2 mole of sulfur. Now remember, if the mole ratio, the number in front of iron is 1 and the number in front of sulfur is 1, meaning that the mole ratio for these guys is simply 1 to 1. So if the mole ratio is 1 to 1, the moment you find the number of moles, then you pick up the one with the smallest number of moles. That's the limiting reagent. So in this case, I can say between the two, iron has the smaller number of moles. Therefore, I can simply say that iron is the limiting reagent or reactant, if you want. So that's the conclusion that we make. Why? Because from the balanced chemical equation, the mole ratio of this reactant is 1 to 1. So when I just calculate the number of moles, the moment you calculate the one with the smallest number of moles will give you which one is the limiting reagent. Okay, so let's move on to a Roman 2 there and show you how we can do that. So can move on to A2 so that we develop some more concepts. So there, A2 simply tells you, A Roman 2 tells us to say calculate the mass of iron 2 sulfide formed in this reaction. So they want us to find what was the mass of the iron 2 sulfide formed in this reaction. So it's always good when you're dealing with masses, it's always good to compare, to check the masses from the balanced chemical equation. So because iron is the limiting reagent, so I'll compare iron with the iron 2 sulfide. I cannot use sulfur because this sulfur is what we call as being the excess reactant. So it is in excess, but so you use the limiting to determine any products that you want. So if I look at iron, let's just quickly do that. There's iron, that's just 56. 1 times 56 is 56 sulfur. 1 times 32 will be 32. So when we add that, I'm going to have 88. So from the balanced chemical equation, the total mass of this guy is 56 grams, and the total mass of this whole iron 2 sulfide is 88 grams. So you can compare the masses from the balanced chemical equation. So what are we going to do? I'm going to say 56 from the balanced chemical equation, 56 grams of iron, produces 88 grams of iron, 2 sulfide. So I'm going to say, suppose, remember the mass of iron that they used was a 5.6. So I'm going to say, suppose I have 5.6 grams of iron, then what mass of iron 2 sulfide will I produce? So we cross multiply there. So when we cross multiply this times that will give me a 56x is equal to 5.6 multiplied by 88. To find x, I'll divide 56. What I do this side, I'll do it the other side. So x therefore will be equal to, if you notice and do your calculation there, it is going to give you 56 there is 1, 56 there is 0.1 times 88. That will give me 8.8 grams of iron, 2 sulfide. So that is the mass they wanted you to get there. So this is the solution that they wanted you to get there. So that's basically how you can go about it. If you want to learn more on how to calculate from a balanced chemical equation, please check out my other videos. Otherwise, it's that simple. There are so many ways of finding that one. Let's go and look at B. B says calculate the mass of the excess reactant that is left after the reaction. So they want us to know what was the mass of the excess reactant. We know the excess reactant is that. So let's try to see how you can go about that. I'll leave the equation. So let's see how we can go about that. So for the B part there, I'm going to say the excess, so I'm going to compare the two. I know the total mass of sulfur there will just be 32 grams from the balanced chemical equation. So I'll compare the two guys now. I'll say from the balanced chemical equation, 56 grams of iron requires 32 grams of sulfur. So I'm going to say, what mass did they use? It's actually 5.6. So you're going to say, what about 5.6 grams of iron? Then what mass of sulfur does it require? You don't know. So you put X there. Then we can cross multiply. This times that. That is again going to give me 56X is equal to 5.6 multiplied by 32. To find X, I'll divide 56. What I do this side, I'll do it the other side. If you calculate this on your calculator, that will give us just a 3.2 grams of sulfur. So you can imagine, meaning when you use 5.6 grams of iron, you only need 3.2 grams of sulfur. So you only need to use 3.2 grams of sulfur. You can see, and how much mass of sulfur were we given? If you notice, we were given 6.4, meaning if I only use this, I'll still remain with something. That's why sulfur is in excess. So the question was saying calculate the mass of the excess reactant. So therefore, I can simply say mass of excess. In this case, it's the sulfur. The mass of excess sulfur. I'll get what was the total mass of the sulfur that they had. It was 6.4 grams. But what do I need to use out of that? I only need to use 3.2 grams. So if you subtract that, you still remain with 3.2 grams. So that was actually the mass that was in excess. So that's the way you can calculate that. Thank you so much, and see you in my next video when we talk about now, we'll talk about dilution and how to go about it.